Good morning, myself Professor Reddy, Department of Bioinformatics. Today we are going to discuss about the topic DNA sequence alignment. So, before getting into the actual topic, let us see the vision of the Department of Bioinformatics. So, the vision statement of Department of Bioinformatics is to be a leading innovation center in bioinformatics, offering a dynamic curriculum aimed at producing globally competent, employable, entrepreneurial and research professionals with ethical values capable of addressing challenges in multiple domains. If you carefully go through the vision statement of Department of Bioinformatics, so it is a leading innovation center which is aimed at producing globally competent, employable, entrepreneurial and research professionals with ethical values who are capable of addressing challenges in multiple domains. This is about the vision statement of the Department of Bioinformatics. Coming to the mission statements. So, the Department of Bioinformatics has 3 mission statements aimed at 3 different aspects, 3 different attributes. So, the first mission statement is towards the employability. Second mission statement aims towards higher education and research, and third mission statement mainly focuses on developing entrepreneurial capabilities. So, let us go through this first mission statement. So, the mission statement, first mission statement offering the state of art curriculum with skill based practices in teaching and learning to equip bioinformatics student for employment. So, first mission statement mainly focuses on creating employment opportunities for the students. Coming to the second mission statement, providing advanced computational and laboratory resources to prepare students for higher education and research. So, the second mission statement mainly focuses on higher education and research. Coming to the third mission statement, shaping well-rounded professionals with ethical values, leadership qualities and teamwork skills for lifelong learning. So, the third mission statement mainly focuses on developing leadership qualities and building teamwork skills for lifelong learning. So, these are the 3 mission statement of Department of Bioinformatics. Coming to the program educational objectives. So, there are 3 program educational objectives in the Department of Bioinformatics. Coming to the first program educational objective, it mainly focuses on identifying and analyzing biological data using computational tools to design drugs through structural biology approaches. The first statement mainly focuses on identifying and analyzing data which is in biological databases and computational tools mainly to design drugs through structural biology approaches. Coming to the program educational objective 2, PEO2, develop predictive solutions to explore biological processes focusing on genomics, proteomics and metabolomics. So, program educational objective 2 mainly focuses on exploring solutions for biological processes focusing mainly on genomics, proteomics and then metabolomics. Coming to the PEO 3, program educational objective 3, it demonstrates technical expertise, communication and entrepreneurship to foster professional growth and interdisciplinary leadership. Coming to the program specific outcomes, there are 2 program specific outcome statements. So, the first statement, program specific outcome 1, develop bioinformatic algorithms and computational tools to address challenges in biotechnology including genome assembly, protein structure prediction and docking. Coming to this program specific outcome 2 statement, to facilitate the use of biological databases and computational tools to analyze and interpret data, providing domain expertise to support research in the field of life sciences. So, coming to the contents that we are going to discuss today. The first one is what is an alignment, the different types of alignment, followed by dynamic programming and then types of alignments. There is one global alignment followed by local alignment and finally, we are going to summarize the topic. So, coming to the objective of this particular topic, the objective of this course is to equip students with skills and to help them use computational methods to study, organize, analyze and interpret biological data at molecular, genetic and genomic levels. Coming to the outcome, so student will be able to query biological data, interpret and model biological information, and he will be able to apply this for various biological problems in any arena involving molecular data. Next, coming to this topic, alignment. What is an alignment? So, this alignment is mainly used to uncover homologies between two sequences. It is mainly used to uncover homologies between two sequences and then combined with phylogenetic studies. So, what is this phylogeny? Phylogeny is nothing but here we are able to find out the evolutionary relationship between the given set of organisms, and here we can also determine orthologs and paralogs relationships. Coming to these types of alignment. So, there are two types of alignment. The first one is the global alignment and second one is the local alignment. So, global alignment is defined as alignment of a pair of sequences along their entire length, and this global alignment is carried out by using the algorithm Needleman-Wunsch. Coming to the local alignment, local alignment is defined as alignment of a pair of sequences along their conserved regions, and local alignment, it makes use of the algorithm Smith-Waterman. Coming to this dynamic programming. So, what is this dynamic programming? So, dynamic programming is defined as alignment of a pair of sequences. Pair is nothing but two sequences. Alignment of a pair of sequences either globally or locally using Needleman-Wunsch algorithm or Smith-Waterman algorithm. So, the definition of dynamic programming tells us about two types of alignment. The first one is the global alignment and the second one is the local alignment. It also tells us about two algorithms which are used for this alignment process. So, for global alignment we will make use of the Needleman-Wunsch algorithm, and for local alignment we will make use of the Smith-Waterman algorithm. So, dynamic programming is solving complex problems by breaking them into simpler sub problems. So, dynamic programming is nothing but solving complex problems by breaking them into simpler sub problems. So, the two algorithms, the first one is the Needleman-Wunsch algorithm which is used for global alignment. So, here in this Needleman-Wunsch algorithm where, so Needleman-Wunsch were the first to propose this method. So, here maximize a score of similarity to give maximum match. So, for match positive value will be assigned, maximize match equivalent to larger number of nucleotides that can match with others, then that want to quantify sequence similarity between two sequences. So, for us to perform this global alignment we need two sequences, sequence 1 and then sequence 2. So, here in this we are trying to align sequence 1 with the sequence 2. In this process we want to find out the maximum similarity which will ultimately lead to maximum score. So, coming to this dynamic programming. So, dynamic programming in sequence alignment, there are 3 steps in dynamic programming. Coming to the first step. So, the first step, there are 3 steps in dynamic programming. First step is the initialization step, second step is the matrix filling, and final step is traceback. So, coming to this first step. So, the first step in global alignment dynamic programming approach is to create a matrix with m plus 1 columns and n plus 1 rows, where m and n correspond to the size of the sequence which is need to be aligned. So, let us take here two sequences. So, the first sequence consists of 4 characters and the second sequence consists of 3 characters, where we are going to plot first sequence along x axis and then we are going to plot the second along the y axis. So, this is nothing but initialization step. Second step is matrix filling. So, here we will fill the matrix with highest possible score. So, in the matrix filling step we are going to fill each and every cell in the matrix with the highest possible score. So, the highest possible score is calculated in 3 different directions. The first one is change in row, second one is change in column, and third one is change in both row and column. And the last step is trace back. So, that is nothing but moving from the last corner to the origin. So, coming to this local alignment. So, local alignment is nothing but alignment of a pair of sequences using Smith-Waterman algorithm. So, it is a part of dynamic programming. So, here again we will have m rows and then n columns. So, again here we will have 3 steps: initialization step, matrix filling step and then trace back step. So, first step is initialization, second step is matrix filling and last step is trace back. So, in local alignment, trace back will be done from the box with the highest value. So, here the 2 strings are, this is string 1 and then this is string 2, and then here we are assigning values. For match, positive value of 1 is assigned, for mismatch 0 is assigned and for gap 0 is assigned. So, for match positive value of 1, for mismatch value of 0 and for gap value 0 is assigned. So, the algorithm used for local alignment is Smith-Waterman algorithm. So, Smith-Waterman algorithm gives us 4 conditions: condition 1, 2, 3 and then 4. So, let us see these 4 conditions. So, here the 4 possible conditions are right. So, here this is the, let us take as a graph. So, near origin the 2 coordinates are 0, 0. So, the address of this point is f of I comma j. So, where I denotes rows, j denotes columns. Rows are always horizontal, columns are always vertical, right. So, as we move up, then there is change in the row. So, that is nothing but I minus 1 comma j. So, as we move to the left, change in column I comma j minus 1. So, as we move diagonally, there is change in both row and column, which is defined as I minus 1 comma j minus 1, right. So, here you can see the 4 possible conditions: f of I comma j on the LHS side and the 4 possible conditions. So, I minus 1 comma j minus 1, which indicates change in both row and column, where S stands for sigma or summation x I and y j. So, along x axis we are going to plot rows, along y axis we are going to plot columns. Similarly, I minus 1 indicates change in row where column is fixed. I comma j minus 1 indicates change in column where row is fixed, and then we are going to calculate value for each and every possible condition. So, once all the values are calculated, then we are going to pick the max of the 3 values. Let us suppose if all 3 of them gives negative value, that is change in row and column, change in row as well as change in column. If all 3 of them gives negative value, then we are going to ignore all these 3 and then we are going to pick the 4th condition 0. So, this 0 is termed as predefined 0. Why it is predefined 0 means it is defined in the algorithm as one of the 4 conditions. So, Smith-Waterman algorithm gives us 4 conditions. The first one is predefined 0, the second one is change in both row and column, third condition is change in row and fourth condition is change in column. So, when this predefined 0 is taken, so when both change in row and column, change in row as well as change in column, if all 3 of them gives us negative values, then we are going to ignore all these 3 and then we are going to pick the predefined 0. So, let us see this. So, here the 2 strings, this is string 1 and then this is string 2. So, string 1 is plotted along y axis and string 2 is plotted along x axis. So, let us number this, right. This is column number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Coming to this 1, 2, 3, 4, 5, 6, 7. So, this is a matrix of size 7 rows into 11 columns. So, the total number of cells will be 77. So, here we are going to calculate value for 77 cells in the matrix table by using the algorithm Smith-Waterman. As we have seen, Smith-Waterman algorithm gives us 4 conditions: change in row, change in column and then change in row and column. If all 3 of them gives negative, then we are going to take the predefined 0. So, as we have seen in the previous slide, the value for match was assigned 1, mismatch zero, and then gap was assigned 0. match 1, mismatch 0 and then gap 0. So, the value which was assigned for match was 1, mismatch 0 and then gap 0. So, here there are two strings, the first string plotted along x axis and the second string plotted along y axis. The one which are plotted along x axis we call them as rows, the one which is plotted along y axis we call it as columns. So, here the number of strings in the row are 7 and the number of characters in the string which is plotted along y axis are 11, right. So, coming to this first cell where row coordinate and column coordinate is defined as 0, 0, it is as simple as in the graph. So, near origin the x coordinate and y coordinate are simply defined 0, 0, same as the case, right. So, as you move one step ahead means one gap is created. So, the value which was assigned for gap was 0. So, it is 0, again second gap, third gap, 4, 5, 6, 7, 8, 9, 10, right. Similarly, along x axis, so along x axis one gap, 2, 3, 4, 5, 6, 7. Next, coming to this first cell. So, the address of this first cell is f of I comma j. So, the address of this first cell in this matrix is f of I comma j. So, as you move up, so there is change in row. So, initially the row value was 1, now the row value is 0. So, as you move up there is a change in row by 1. So, the value in this I minus 1 comma j is 0 and then gap is 0. So, the value obtained in this direction is 0. Similarly, as we move to the left, change in column, first column is made the 0th column. So, the value in I comma j minus 1 cell is 0, I comma j minus 1 cell is 0 and then I comma j minus 1 is 0 and then minus d. So, it is and then 0, 0 minus 1 minus 1 and then diagonal box. So, the address of the diagonal box is I minus 1 comma j minus 1. So, the value in I minus 1 comma j minus 1 is 0. Then, so the row coordinate is g, column coordinate is g. So, g versus g is a match. So, 0 plus 1 is 1. So, the three possible values are 0, 0 and then 1. So, the three possible values are 0, 0 and 1. So, the max of these three values is 1. So, value 1 is assigned for this particular cell and then the direction. Coming to the second cell, same is the case, the address of this cell is f of I comma j. So, as you move up there is change in row. So, the value in this change in row is 0 and then gap is 0. So, 0 minus 0 is 0. Similarly, change in column, the value is 1. So, I comma j minus 1 value is 1 and then minus d is 0. So, 1. Similarly, so that the value in the I minus 1 comma j minus 1 cell is 0 and then row coordinate is g, column coordinate is a, mismatch value of 0. So, 0 plus 0 is 0. So, the three possible values are 0, 0 and then 1. So, the max of these three values is 1 and direction is from the change in the column. Similarly, for this particular cell, so change in row is 0. So, 0 minus 0 is 0, change in column is 1, 1 minus 0 is 1, change in both row and column is 0. So, row coordinate is g, column coordinate is a, mismatch. So, the value for mismatch which was assigned was 0. So, 0 plus 0 is another 0. So, the max of these three values is 1, that is change in the column. Coming to this cell, so change in the value in this change is 0 is 0, 0 minus 0 is 0. Similarly, change in column 1, 1 minus 0 is 1, change in both row and column value is 0, row coordinate is g, column coordinate is t. So, g versus t is a mismatch. So, another 0. So, the maximum value among these three is 1, that is change in the column. Similarly, for this particular cell, value with respect to change in row is 0. Similarly, with respect to change in column is 1, with respect to both change in row and column is 0. So, the maximum value of 1. Similarly, for this particular cell change in row is 0, change in column gives us the value of 1, change in both row and column gives us the value as 0. So, the maximum value is 1. Same is the case with respect to the next cell, change in row is 0, change in column is 1, change in both row and column is 0. So, the maximum value is 1. Similarly, for this next cell change in row is 0, change in column is 1, change in row and column. So, here I minus 1 comma j minus 1 is 0. Similarly, with respect to row coordinate is g and column coordinate is g. So, it is 1. So, the value of 1 is obtained in two directions, that is both change in column as well as change in both row and column. So, if maximum value is obtained in more than one direction, then we are going to indicate it by providing arrows in more than one direction, which implies this particular value of 1 in this cell in this matrix is obtained in two directions, that is change in column, similarly change in both row and column. Similarly, for this particular cell in the matrix table, change in row gives us value of 0, similarly change in column gives us value of 1. With respect to both change in row and column, it gives us value of 0. So, the maximum value is 1. Same is the case for this cell, change in row gives 0, change in column gives us the value of 1. Similarly, both change in row and column gives us the value of 0. So, the maximum among the three values is 1. With respect to this cell in this matrix table, change in row gives us the value of 0, change in column gives us the value of 1, change in both row and column gives us the value of 0. So, the maximum of among the three is 1. Similarly, for this cell in the matrix, change in row, that is I minus 1 comma j is 1 and minus j is 0. So, it gives us value of 1. Coming to this change in column, so the value in I minus 1 comma I comma j minus 1 is 0. So, 0 minus 0 is another 0. With respect to change in both row and column, the value in this I minus 1 comma j minus 1 is 0. Coming to this row coordinate is g, column coordinate is g. So, it is a match, the value assigned for match is 1. So, it is 1. Here for this particular cell, maximum value of 1 is obtained in two directions, that is change in row as well as both change in row and column. So, here we are assigning value of 1 for this particular cell in the matrix, and coming to this cell, change in row gives us I minus 1 comma j is 1. So, it gives us the value of 1, right, and coming to the change in column. So, the value in I comma j minus 1 is 1, and then so it is 1, and then coming to this diagonal I minus 1 comma j minus 1. So, the value is 1, and then row coordinate is g, column coordinate is a, mismatch, the value for mismatch is 0. So, 1 plus 0 is 1, right. Here the positive value of 1 is obtained in more than one direction. So, if all three of them gives the same value, then priority should be given to the cell where both change in row and column is noticed. Coming to this cell, change in row, that is 1, similarly change in column again 1, and coming to this change in both row and column. So, diagonal value is 1, g versus a mismatch, right. Again the maximum value of 1 is indicated. Same is the case for this cell where the maximum value of 1 is obtained, same is the case where we are going to assign the value 1. And coming to this particular cell in the matrix table, here we can clearly see. So, change in row gives us the value of 1, change in column gives us the value of 1. Coming to this diagonal, the value is 1, where row coordinate is g, column coordinate is also g. So, g versus g is a match, the value for match is 1. So, the diagonal value of 1 plus 1 gives 2. Coming to this cell in the matrix table, change in row, change in column, and then it gives the value of 2. Same is the case with this cell, both the cells where the value is 2, 2 and then 2. So, similarly for this particular cell in the matrix table, change in row gives the value of 1, change in column gives the value of 0, both change in row and column, that is 0, and then A versus G, it is a mismatch. So, the maximum among the 3 values is 1. So, this particular cell is assigned value of 1. Coming to this cell in the matrix table, change in row 1, change in column 1, coming to this diagonal box where there is both change in row and column, that is 1, and then row coordinate is A, column coordinate is A, match is having positive value of 1. So, 1 plus 1 it comes to 2, and then direction next. So, coming to this cell, change in row 1, change in column I comma j minus 1 is 2. So, 2 minus 0 is 2, coming to this diagonal box. So, diagonal box, the value in the I minus 1 comma j minus 1 box is 1, row coordinate is A, column coordinate is also A. So, A versus A is matched, the positive value of 1. So, already the value in the diagonal box is 1. So, 1 plus 1 gives rise to 2. With respect to this cell in the matrix table, so change in row 1, change in column 2, and then change in both row and column gives the value of 1. So, maximum value of 2, and coming to this cell, change in row is 1, change in column is 2, and then change in both row and column, A versus T mismatch. So, mismatch is right. So, here positive value of 2. So, change in row 1, and then change in column 2, and then row coordinate and column coordinate A and C are mismatch 1, next 1, change in this is 2, change in both row and column is 1 A. So, here positive value of 2, coming to this cell again change in row 2, change in column 2, and then diagonal value, both row coordinate is J and column coordinate is A, mismatch. So, 1. So, here more than one direction. Similarly, so we are going to calculate the value for this cell, change in row gives 1, change in column gives 2, and then change in both row and column, mismatch is 0, again 2, more than one direction. Next, similarly, we are going to calculate the values for this cell in the matrix, change in row, change in column, change in both row and column. Next, similarly for this cell, change in row, change in column, change in both row and column gives positive value of 3. Similarly, here for this particular cell where the address of this cell is f of I comma j, change in row I minus 1 comma j 1, change in column I comma j minus 1 is 0, diagonal change in both row and column is 0, and then mismatch. So, maximum value of 1. Similarly, for this particular cell in the matrix table, change in row 2, change in column 1, diagonal change in both row and column, A and T are mismatch. So, 1. Similarly, for this cell in the matrix table, change in row 2, change in column 1, and then change in both row and column 2. So, here 2 in more than one direction. Similarly, for this particular cell, change in row is 2, change in column is 2, change in row and column is 3. Similarly, for this particular cell, change in row is 2, change in column is 3, change in row and column 2 plus 1 3, more than one direction. Similarly, for this particular cell, change in row is 2, change in column is 3, both row and column is 2. So, maximum value of 3. Similarly, for this cell, change in row is 2, change in column is 3, change in both row and column is 2. So, maximum value of 3. Similarly, for this particular cell, change in row is 2, change in column is 3, change in both row and column is 2. So, maximum value of 3. Similarly, for this cell in the matrix table, change in row is 2, change in column is 3, change in both row and column. So, here the two coordinates are t and t match, positive value of 2. So, here maximum value of 3 is obtained in more than one direction. Similarly, for this cell in the matrix, change in row is 2, change in column is 3, change in both row and column matrix cell, here positive value of 3 in more than one direction. Similarly, for this cell, change in row is 3, change in column is 3, change in row and column is 2. So, here positive value of 3 is obtained in more than one direction. Similarly, for this cell, change in row is 1, change in column is 0, both change in row and column is 0. So, here positive value of 1 in one direction. Similarly, for this cell in the matrix, change in row is 2, change in column is 1, change in row and column it is 1. So, here positive value of 2. Similarly, for this cell, change in row is 2, change in column is 2, change in row and column is 2. So, here more than one direction. Similarly, for this cell, change in row is 3, change in column is 2, change in row and column is 2. So, positive value of 3, maximum value is obtained in change in row. Similarly, change in row is 3, change in column is 3, change in both row and column is 3. So, maximum value of 3 in the diagonal direction. Similarly, for this cell, change in row is 3, change in column is 3. With respect to both column and row change, that is diagonal value of 3 plus C versus C, it is 1. So, maximum value of 4 in the diagonal direction. Same is the case with respect to this cell, change in row is 3, change in column is 3, change in row and column is 4. So, maximum value of 4, change in row is 3, change in column is 4, change in both row and column that is 3. So, positive value of 4, maximum value obtained in change in column. Same is the case with respect to this box, change in row is 3, change in column is 4, change in both row and column it is 3. So, maximum value of 4, same with respect to this cell, change in row is 3, change in column is 4 and then change in both row and column that is 3. So, here maximum value of 4 is obtained, where 4 is the max value which is obtained because of change in column. Similarly, with respect to this cell, change in row is 3, change in column is 4, with respect to change in both row and column mismatch. So, it is 3. So, ultimately 4 is the maximum value with change in column. Similarly, for this cell in the matrix table, change in row gives us positive value of 1, change in column gives positive value of 0, change in both row and column. So, here G versus G is a match. So, here positive value of 1. So, 1 is obtained in more than one direction. Here we are going to assign value of 1. Similarly, for this cell, change in row is 2, change in column is 1, change in both row and column 1. So, positive value of 2. Similarly, for this cell, change in row is 2, change in column is 2 and then both change in row and column. So, positive value of 2. Similarly, for this cell, 3 is obtained because of change in row. Similarly, for this particular cell, positive value of 3 obtained is change in row. Similarly, for this particular cell, 4 because of change in row. For this cell, again change in row. For this particular cell, change in row gives positive value of 4, change in column again gives positive value of 4, change in both row and column gives positive value of 5. Same is the case for this cell, change in column and then change in column. Coming to this last row, so here change in row gives the maximum value of 1, here change in row gives the maximum value of 2, change in here maximum value of 2 is obtained in the diagonal. So, coming to the last step, that is trace back. So, if you carefully go through the values in all the 77 cells, the maximum value is 6, which implies this particular, so which implies that we are going to do the trace back step from the last cell. So, coming to this cell, so for this particular cell the row coordinate is A and column coordinate is also A. So, row coordinate is A, column coordinate is also A. So, this particular value of 6 is obtained in the diagonal direction. So, for this particular cell row coordinate is G and column coordinate is T. So, this particular value of 5 is obtained in the horizontal, that is change in column, which implies that there is no change in the row, but change in column is seen. So, for this particular cell the column coordinate is T, whereas the row coordinate is G. Coming to this cell, this particular value of 5 is obtained again from change in the column, right. So, coming to this particular cell, so the row coordinate is G and then column coordinate is, row coordinate is G and column coordinate is T. Since there is no change in the row, so row component is mapped with the gap, and coming to this particular cell 5, it is obtained in the diagonal direction where the row coordinate is G and column coordinate is G. Coming to this particular cell, this value of 4 is obtained in the change in column. So, when you move from this cell to this cell, row coordinate is same, but whereas change in column coordinate. So, for this particular cell row coordinate C is fixed, whereas column coordinate is A. So, it is filled with the gap, and coming to this particular cell, this 4 is obtained in the diagonal direction. So, the row coordinate for this cell is C and column coordinate is C, right. Coming to this cell, this is obtained in the diagonal direction where the row coordinate is D and then column coordinate is D, and coming to this cell, this particular value of 2 is obtained in the change in the column. So, for this cell there is no change in row, but there is change in the column. So, it is T versus gap. Coming to this value of 2, it is obtained in the diagonal direction. So, for this particular cell the row coordinate is A and column coordinate is A. Coming to this cell, this particular value is 1 is obtained in the diagonal direction, where the row coordinate is G and column coordinate is A. Row coordinate is G, column coordinate is A, and coming to this cell, it is obtained from the origin where the row coordinate is G as well as column coordinate is also G. So, if you carefully go through these two strings, the first string has 11 characters 1, 2, 3, 4, 5, 6, right, and the second string has 7 characters. As we have seen in the previous slide, match was assigned a positive value of 1, mismatch was assigned value 0 and gap was assigned value 0. So, coming to this, the number of matches 1, 2, 3 and then 4, 5. So, the total number of matches are 5. So, match, so the possible matches, right, 1, 2, 3, 4, 5, 6. So, the total number of matches were 6 and then mismatches were 1 mismatch. So, the contribution from mismatch is 0 and then the number of gaps 1, 2, 3, 4. So, the contribution from gaps was 0. So, the total value is 6. So, the calculated value is 6, alignment value is also 6. So, when calculated value is equivalent to alignment value, then our procedure is correct. So, this is how this traceback step is done with respect to the local alignment. So, in local alignment, traceback is done from the box with the highest value. So, we have started it from the lowest corner and then finally, we have done the traceback and ultimately we have reached the origin where both row and column coordinates are 0 and 0 and the alignment score was 1, calculated score was alignment score was 6, calculated score was also 6. So, when calculated value is equivalent to alignment value, then the procedure is correct. So, once this matrix is filled, the last step is back tracing. So, after the matrix fill step, the maximum alignment score for the two test sequences is 6. So, the traceback step determines the actual alignment that result in the maximum score. So, where calculated value was 6, alignment value was 6 and maximum score was also 6. So, with respect to global alignment, traceback will be done from the box with the highest value. With respect to the local alignment, traceback will be done from with respect to global, traceback will be done from the last box. With respect to the local, traceback will be done from the box with the highest value. So, coming to the total value 1, 2, 3, 4, 5, 6. So, in this way we can align sequence using dynamic programming. So, coming to the summary. So, global alignment is done for the two sequences. So, with respect to the traceback for global alignment, traceback will be done from the last box irrespective of the value in the box, whereas the algorithm used for global alignment is Needleman algorithm. Similarly, for local alignment, traceback will be done from the box with the highest value, and local alignment is mainly carried out for finding out the conserved regions, which ultimately gives us about phylogeny, and traceback with respect to local alignment is always done with the box with the highest value. So, the possible questions from this topic, first one is the concept of dynamic programming, where we need to define dynamic programming, followed by the types of alignments, global alignment, then local alignment, and then Needleman-Wunsch algorithm, and then Smith-Waterman algorithm. So, the second question is about the Needleman-Wunsch algorithm, where two strings need to be taken and then alignment of two strings need to be carried out. Similarly, with respect to the third probable question, Smith-Waterman algorithm, again two strings need to be taken and then the two strings need to be aligned using local, and then here already two sequences are provided, and this particular sequence global alignment need to be carried out by using Needleman-Wunsch algorithm. Similarly, for the two strings mentioned over here, local alignment can be performed by using Smith-Waterman algorithm. Similarly, with respect to two protein sequences, global alignment again by using Needleman-Wunsch algorithm. Similarly, for two protein sequences, local alignment using Smith-Waterman algorithm. So, the probable reference books are Zenzion, David Mount, Atwood and Smith, Arthur Lesk. Thank you.